I am Lucas.
I am Pavan.
I'm Sri, and we are Team Aquamen from Singapore.
When you hear the term oil spills, you probably picture massive tankers discharging tons of oil into the ocean, covering the water with a layer of black sludge.
However, that just scratches the surface. In order to see how oil spills affect our ecosystem, we need to take a dive below the surface.
Surface contamination is a result of the formation of crude oil emulsions in the water. Beneath the surface, crude oil forms micelles or liposomes, which can be ingested by marine organisms.
In fact, crude oil also contains harmful compounds such as benzene, toluene, and even mercury. From our research, we found that these harmful subsurface emulsions persist for longer in fresh water than in seawater.
The beard of Poseidon. Freshwater oil spills actually occur more frequently than in the sea, albeit in lower volume. What's worse is that freshwater ecosystems are extremely diverse, and a single oil spill could irreversibly upset the delicate balance by causing the extinction of a keystone species.
There have been very few oil spill cleanup solutions that deal with subsurface contamination, and hence we are pioneering this novel field of research. Hence, we use precision ellipsometry, an optical technique, to determine the degree of binding of crude oil to various solvents.
PREL involves shining elliptically polarized laser light at a substrate, which reflects the polarized light into a system which measures the thickness of the film on the substrate. The technique uses the degree of rotation or polarization of the laser to determine the thickness of the layer bound to the substrate. This is directly linked to the strength of intermolecular forces between the compound and crude oil, hence describing the degree of binding.
We tested the binding of several compounds to crude oil in freshwater on a hydrogen-terminated silicon substrate, and of these solvents, glutaraldehyde, bovine serum albumin, showed significant binding to crude oil.
White serum albumin is an expensive protein. Hence, cost-effective proteins such as soybean proteins, which are available in large abundance, can be used as an alternative. Our prototype aims to use a solvent-lined belt, which extends below the surface of the water in order to absorb oil droplets present below the surface after other methods such as skimmers have taken care of the surface level contamination.
Once again, we are Team Aquaman. Bye!